Hi everyone. We recently launched gluestack-ui v3. The main motive behind it was to make the contributions in gluestack-ui super smooth and simple. Whether it's fixing a bug, building new features or components, or updating the docs, contributing is easy and open for everyone. In this tutorial, I'll walk you through the steps of contributing to gluestack-ui so you can get started right away. Your contributions are always welcome, and the GlueStack team can't wait to see what you'll bring in. Let's start by opening the gluestack-ui repo on GitHub. Inside, you'll find the contribution guide. Make sure to give it a quick read before you get started. Now, let's fork the repo so we can start making changes. Let's have a quick overview of the repository. We use a source destination architecture here. All the main apps are linked to the src folder through mappers and scripts, which means any changes in src folder automatically get pushed to each app. The coolest part is hot reloading. As soon as you change something in src, it updates instantly in the app. For packages, we use Yelk for local testing. Nodman keeps an eye on the package folders and pushes updates through Yelk, so everything stays in sync. Alright, let's take a look at the package structure. All the packages live inside the packages folder. There are two main ones you'll work with. gluestack-ui utils. This has all the utility stuff like accessibility helpers, hooks for figuring out layouts, for example, checking keyboard position, and native wind utilities. gluestack-ui core. This is where the actual functionality of all components lives. So, whenever you're building a new component, you should define all of its logic inside gluestack-ui core. When the component is published, all that functionality gets shipped into the user's node modules. Now, let's talk about how we test these packages locally. We use a tool called Yelk. It basically works like a local npm registry. Here's how it goes. Whenever you make a change inside the package's src folder, Nodman picks it up. The scripts then automatically rebuild the package, even for tiny changes, and push the latest build to the Yelk store. Since our apps are linked to this Yelk store, they always use the latest local build of the package. So in a way, we get hot reloading for package testing too. We'll now set up the repo for local development. Let's install all the required dependencies for the project. Next, let's sync all the components to our apps. Let's run the watcher so we can see our changes live. This command starts the watcher, which keeps the apps in sync with real-time updates. Any change you make will show up instantly. Alright, let's build the packages and push them to the Yelk store. We've already got a command for that, so let's just run it. And the nice part is, it also keeps watching for changes and continuously pushes the latest build to the Yelk store. Let's install all dependencies for our apps too. Next, we also need to link our apps to the Yelk store, and we already have a command for that too. Great, our apps are ready to go. Time to run them and see everything in action. Perfect, our apps are up and running. Let's start playing around with our mappers. In the terminal, you can see that every time we change something in the src folder, the watcher runs and pushes those changes directly into our apps. The src folder holds components and their documentation. In the UI directory, each component has its styling, example usage, and a dependency.json for any extra dependencies used. We will start by editing the button component. For example, Let's change its background color to red 400. Let's check changes. Let's also tweak the docs a bit. We'll change this button text to loading. To do that, we just need to update the template.handlebars file for that example. Let's check changes. Let's add an example for the button component to show how it can handle a drawer. First, we'll create a folder called drawer handling. Then, we'll add the corresponding meta.json and template.handlebars files inside it. Finally, we'll pass a reference to this example in the docs file so it shows up properly. The meta.json file includes all the imports and argument types you need to show in the controls. Right now, I'm not passing any arguments, but you can also add a title and description for the example in this file. The template.handlebars file is where you put the JSX code for your example. Basically, it defines how the example will render. Here I've shown how to pass a reference to the docs file for the example. Just make sure the example folder name and the reference you pass are exactly the same. Otherwise, it won't link properly. We've seen how mappers and local package testing works. Now let's build a new component. We already have a command that generates a basic component template, so we don't need to start from scratch. Let's use that to spin up something new. This time, a tabs component. The command will ask for a few details about the component. Let's name it menu tabs. It's a layout component. We'll include the creator functionality and skip the aria functionality for now. Great. It's set up all files for the template on its own. Let's take a quick look at the generated component before we start editing it and adding our custom logic. Right now, it's looking really basic. Let's also check how it's looking in apps. Let's check its docs. Nice. The basic component template is now set up everywhere. Here's where we can add the logic for our component. The scripts will automatically build it and push it to the apps. You'll notice in the terminal that whenever we make changes in the packages folder, the script triggers in and starts working. After the scripts push the changes to the Yelk store, the apps pick them up through the Yelk folder. Essentially, it works just like Node modules, letting the apps use the updated packages immediately. Alright, so the component is now complete. I've set up a dedicated styling file for it, added the functionality inside the packages, and also defined the docs to go along with it. Let's see how it looks in our apps. Great. You can test the component in both Next.js and Expo environments. That's the main goal of the whole V3 rework. So here's what happens when you raise a PR. As soon as you push your changes, GitHub Actions triggers in and checks if there are any updates inside the packages folder. If it finds something, it automatically builds a preview package and publishes it to npm with a preview tag. That preview package is then picked up by Vercel to create a live preview build of the app using your updated package. The nice part is, right inside the PR, the admin or reviewers can just click the link and see your changes running live. No need to pull code or set things up locally. Now, if everything looks good and the PR gets merged, the package is published to npm properly and Vercel triggers a production deployment. If the PR isn't merged, nothing gets published and no deployment happens. In both cases though, the cleanup of those preview packages on npm is automatically handled by scripts, so you don't have to worry about leaving junk behind.